Hi, hello friends, welcome to the channel. Today in previous session we studied what is Poisson's ratio, how longitudinal strains and lateral strains are formed. In this section we will be seeing how volumetric strains are formed. In first we'll say what this elastic constants. This elastic constants is what, let's see. We have yesterday we saw the relation Poisson's ratio mu is equal to longitudinal lateral strain upon longitudinal strain. Yesterday we just see how this equation was formed, this relation was formed. In order to equate this lateral strain and longitudinal strain, we need a constant mu. Similarly, for relating any equations, we have to for seeing any relations between any two strains, we need some constants. We are just studying forces, how forces act on a material within elastic limit only. That's why we got the name elastic constants. We needed constants. The constants are particularly used to study how forces act on materials, how the strains are formed within elastic limit only. Hence the name came as elastic constants. Today we are going to have a session on volumetric strain. Volumetric strain. Volumetric strain. This volumetric strain is denoted by EV. Okay. Volumetric strain is nothing but, let us have a material is in rectangular shape, cuboidal. Okay. It is acting upon forces on all the directions, not one but all. If you can't imagine this, just imagine that the material is immersed inside water. Let it be Indian Ocean. Okay, let's see that this is surface of water. This is the Indian Ocean. Okay, Indian Ocean. Okay, we are Indians, so let it be the Indian Ocean. Someone dropped it when a boat was going. Let it be. It's dropped a container or something, a material. Then what happens? The forces act on this on all the directions, because whenever we go down the ocean, we'll have more and more pressure. Note this point. This is very important. We'll be studying this topic in hydraulic stress in fluid mechanics. Okay. This hydraulic stress is similar to volumetric strain. Hydraulic strain is similar to volumetric strain. That's why I'm going to have the example of hydraulic strain. When you're immersed in water, you'll be having forces on all the directions. Similarly, in volumetric strain, we'll have forces on all the directions. What is strain? What is strain? Strain is change in dimension to original dimension. Here, change in volume to original volume. When forces act upon this material, the material changes its size, changes its volume. If this material is this much big, it will be changing its length to this much. Okay, I'll make a neat one so that you guys can understand. Okay, this will be converted into a small box, so small box. It's acting upon forces on all sides. If all forces compresses on all the sides and it's turned into a tiny new box. Okay, tiny small cute box. This volume restriction is denoted by EV and change in volume by original volume, delta P by V. Okay, we know volume for so we are taking a rectangular box, cuboidal box, so V is equal to length into breadth into thickness. Okay, thickness or depth, let it be d, depth. Okay, this delta V can be given as length into length plus change in length into breadth change plus change in breadth. So in depth side, depth plus change in depth. Okay, this big box is being converted into a small tiny box when forces are acting on all the direction. What happens? We need EV is equal to E suffix V. Okay, delta V upon V. If we equate this equation here, our length is bigger and both the other dimensions, breadth and depth, are very small compared to this length. Okay, what happens? We will equate and we'll just take the bigger components. So we will omit wherever the constants other than length are coming, length alone are coming. What happens if you multiply this? What will come? Length into breadth into depth plus breadth into depth into change in length plus length into breadth into change in depth plus length into depth into change in breadth. Okay, we'll get these constants and we'll get constants, some constants that in length aren't coming. Neglecting that small constants, small terms, we'll having this divided by length into breadth into depth. If we divide this all things with this, we'll be having changing length upon length plus change in depth upon depth plus change in breadth upon breadth. This will become the equation of this. We can see that volumetric strain is equal to 1 longitudinal strain plus 2 lateral strains. So we can write this as EV is equal to delta L upon L plus delta depth upon depth plus delta breadth upon breadth. We can write this as longitudinal strain plus 2 into lateral strain. Okay, I'm just rubbing this. Okay, longitudinal strain into 2 lateral strains. Longitudinal strains can be written as delta L upon L, and this 2 lateral strain can be written as minus mu into longitudinal strain. We just derived yesterday. Strain. Okay, what the relation becomes? Delta L into L plus minus 2 into the mu into delta L upon L. What this equation becomes? I'm just writing here. EV is equal to delta L upon L into 1 minus 2 mu. This will be the equation. Okay, I'll be rubbing this and writing that. becomes delta L upon L into 1 minus 2 mu. This is the equation of volumetric strain, and we'll be using this in problems solving for gate. This is a very important problem. This is a very important formula, sorry. Okay, let's see a problem on this formula. There is a steel bar. Bar is of rectangular cross section. Okay, you might notice rod is of cylindrical cross section. Okay, this change in the length is given as steel bar. Its length is given as 300 mm. Its breadth is given as 50 mm. Its thickness or depth is given as 40 mm. It is acting upon a pulling force, that is tensile force, by tensile force of 300 kilonewton. Okay, in volumetric strain, not only the forces acts on all sides, but also due to a single force or a single force also, there will be change in volume. Okay, in some conditions they will be given as due to single force there will be change in volume. In most of the exams like SSC JEE, we will be having forces acting on all sides. They will be considering, if force acts on all sides, they will be considered as volumetric strain. If this two strain is acting on tensile, they will be considering as only longitudinal strain and lateral strains. So don't confuse in that. If single system acts also, single force acts on a material, then also volumetric strain happens. Okay. P is equal to 300 kilonewton. Mu, that is Poisson's relation, is given as 0.25. And Young's modulus is equal to 2 into 10 to the power 5 Newton per mm square. Okay, we know volume is equal to length into breadth into depth, equating that to 300 into 50 into 40 will be getting 6 into 10 to the power 5 mm square, so mm cube. Okay, mm cube. We know change in length delta L is equal to PL upon AE. Write it this. You know, force is equal to 300 into 10 to the power 3 into, this is given as 300 divided by A and E. A is 50 into 40 to E is 2 into 10 to the power 5. Okay, 10 to the power 3 and these two zeros, 10 to the power 5 cancel. Here 1 0 is a cancel. If we solve this, we'll get delta L. We'll get this answer as 0.225 mm. But we need delta L upon L. So we will not make this. We will take this L to the bottom and make it here L. So the L here goes away. P upon AE. A we know, P 300 into 10 to the power 3 divided by A is equal to 50 into 40 upon 2 into 10 to the power 5. 2 zeros will get cancelled to this, and solving this we get 150 Newton per mm square. Okay, we got delta L upon L. Now we'll just place, we have to find, okay, I'll just do to find this change in volume. Okay, delta V. We know the formula. We know the formula, delta V upon V is equal to delta L upon L into 1 minus 2 mu. We want delta V, so delta V is equal to delta L upon L, which is got into 150 into V we got as 6 into 10 to the power 5 to 1 minus 2 into 0.25. Okay, on solving this we get delta V, that is 225 mm³. This is the change in volume, and this is the answer for that. This change in volume will be asking, they will be asking, or say the change in volume, and they'll be given this, and this will be asking 2-mark question, I think, in GATE. They'll also be asking in ISRO's also.